Okay, solving systems by elimination. You previously saw, by the way, that's not my dog, that's a neighbor's dog that you hear barking in the background. But solving systems by elimination. You previously solved by graphing and by substitution, and this time it's going to be by elimination. One of the good things about this is that after doing graphing and substitution, I believe you'll find that solving systems by elimination to be a welcome relief. So let's begin. The first one we look at, we've got these two equations, 5x minus 6y equals negative 32, and 3x plus 6y equals 48. If you notice, there's a negative 6y in the first one here, and a positive 6y in the second one. So what you can do is eliminate the y's, because if we add these two equations together, those will cancel each other out. So let's look. Let's begin by adding 5x plus 3x, and we get 8x. The 6x, negative 6x and the 6y, they cancel each other out. And 48 and negative 32 make 16. Now we've just got one variable, and you can always solve when you got one variable. So let's go ahead and do that. Divide by 8 on both sides. That gives us x equals 2. Now that we've got the value of one of the variables, we can go back up to one of our equations up here, and we can plug it in. We've got 5, and instead of x, we're going to put 2 minus 6y equals negative 32. We multiply the 5 times the 2, and we get 10 minus, 10 minus the 6y equals negative 32. We minus 10 on both sides, and that gives us negative 6y equals negative 42. We divide by negative 6 on both sides, and that gives us y equals 7. So when we write our answer, we write our answer in a coordinate pair. So it would be x is 2 and y is 7. So our solution set is 2, 7. One of the things we want to do is we want to check our answer. Now we're not going to be making sure that you check your answers. It's just that it's very important that you do. We hold you accountable for the answer. But if you don't do the checking, you can't be sure that you've got the right answer. So we're going to check our answer. So we'll start out with the second equation. We'll go 3 times x is 2, and plus 6 times y, that's a 7, equals 48. That will be 6 plus 42 equals 48, and 6 plus 42 is 48. So we have a true statement here, which means that our answer of 2, 7 is a correct solution set. Okay, this time if you look in these two equations, we've got a positive y and a positive y. So we can get rid of the y's here, not by adding them together, because that would give us 2y here, but this time we're going to subtract them. So we'll start with the first equation, and we're going to subtract each one of these items. So negative x minus a negative 2x. Well, the minus minus makes it positive, so negative x plus 2x gives us x. Y minus y cancels each other out, and 4 minus 2 is 2. So x is equal to 2. So we come back up here to our first equation, and we put in negative. It's always a good idea to put these, when there's a negative sign, to go ahead and put your substituting item in parentheses in case it's a negative item. Plus y equals 4. We've got a negative 2. The way you get rid of a negative 2 is by adding 2 on both sides. That leaves us with y equals 6. And once again, we're going to check our answer. So we go negative 2 times 2 plus 6 equals 2. That gives us negative 4 plus 6 equals 2, and that is 2 equals 2, and we've got a correct answer, so that means our solution set is 2, 6. Alright, a unique situation here. We've got 10x and negative 5x and negative 7x and positive 3y. Neither one of those can be canceled just by adding or subtracting. So what we're going to have to do is manipulate it a little bit, and as you can see at the top it says solving by multiplying one equation. What can we multiply one of these equations by so that we will have the same number with a variable in each equation? I believe you see it. We're going to multiply the second one by 2. That'll give us negative 10x, and the first one has a 10x also, and they would cancel each other out. And I find it to be very helpful to rewrite both equations because it's easier to make mistakes if you take shortcuts. So we write 10x plus 10x minus 7y equals 2. Now we're going to multiply everything in the equation by 2. So that gives us negative 10x. 2 times 3y gives us 6y. And 2 times negative 3 gives us negative 6. Alright, the 10's cancel each other out. We're left with negative y equals negative 4. Divide both sides by negative 1. And that leaves us with y equals 4. And then we repeat the same process that we've been doing in the previous equations. We come back up here and we go 10x minus 7, and y is 4 equals 2. Alright, that gives us 10x minus 28 equals 2, plus 28 on both sides, and that gives us 10x equals 30. Divide by x, divide by 10 on both sides, and that gives us x equals 3. So our solution set is going to be an ordered pair of 3, 4. Very easy here to make a mistake and put 4, 3 since you solved for y first. But you got to remember the x comes first and then the y. So our solution is 3, 4. We come back up here and check. We go negative 5 times 3 plus 3 times 4 equals negative 3. Once again, we don't hold you accountable for checking, and except in the fact that if you don't get the right answer, then you're held accountable for that. So this gives us plus 12 equals negative 3. Negative 15 plus 12 gives us negative 3 equals negative 3, which confirms that we got the right answer. Okay, multiplying both equations is the hint up here at the top. This time, 5x and 3x don't match, negative 3x don't match up, negative 6y and 11y don't match up. If I multiply this one by 2, that gives me 6. That doesn't match up with the 5. If I multiply, well, see, it makes it a little bit difficult because nothing that you multiply this one by is going to equal this one, and nothing that you multiply this one by is going to equal this one. So what we're going to have to do is multiply both of them by something. So let's look at the 5 and the 3, and what would be the common multiple that we can use in order to get them to be equal? Well, yeah, 3 times 5 is 15. So we're going to make both of these 15s. So let's multiply this one by 3 and this one by 5. So 3 times 5 is 15x. Remember, you got to multiply everything by 3. So that gives us 18y equals 24. Then we multiply 5 times negative 3. That gives us negative 15x plus 55y equals 50. Big numbers here, huh? So we go 15x and negative 15x, they cancel each other out. That leaves us with 37y equals 74. Divide by 37 on both sides. And we come down here and we have y equals 2. Come back to your second equation and we put in 3, negative 3 times x, plus 11 times 2 equals 10. That gives us negative 3x plus 22 equals 10, minus 22 on both sides. And that leaves us with negative 3x equals negative 12. We divide by negative 3 on both sides of the equation, and that leaves us with x equals 4. We come check our answer. We've got negative 3. We've got to use the other equation. 5 times x is 4 minus 6 times y, which is 2, equals 8. That gives us 20 minus 12 equals 8, which is a true statement, which means that we've confirmed that our answer is going to be 4, 2. And that is solving systems by elimination.